Hey guys, we're going to look at evaluating limits analytically. So we're going to use some math to do these. The value of a limit can easily be evaluated by direct substitution if the function is continuous at c. We'll talk about continuity later. But for now, we're going to just learn some properties of limits. So these first couple, the limit of a constant, so the limit of a number equals that number. It's a horizontal line, so it's always going to be that number. So an example of this would be number 2 right here. The limit of 23, doesn't matter what it's approaching here, that function is always at 23, so it's going to equal 23. The next one, the limit of x, as x approaches c, is simply just going to be c, because we're going to substitute c instead of x. So right here, the limit of x, as x approaches 7, replace x with 7, and you get 7. The last one right here is with a power, the limit of x to the power of n. As x approaches c, substitute again. Instead of x, we're going to put c and then raise it to the power. So here's an example of that. The limit of x to the third power, as x approaches 4, direct substitution. X, we want to approach 4, that would be 4 to the third. 4 to the third, if I evaluate that, is 64. So then even more properties of limits are right here. If we multiply by a scalar, we're just going to multiply the limit value by that number. If we have the addition of two functions, we're going to take the limit of each, and then we're going to add them together. These L's and K's that I've gotten come from right here. I'm sorry, I should have said that a second ago. The limit of f of x equals L, the limit of g of x equals k. So they found the limit, and we're just using a variable. Multiplication, again, find the limit of f, the limit of g, and then multiply the values together. Division works a lot the same. Find the limit of f, find the limit of g, and then divide the result. And then we have this next one right here. We have a function inside, so we're going to take the limit of the thing inside, and then we're going to raise it to the power here. So a couple of examples for these as we go. So we have some limit values given to us right here. The limit of f is going to equal p. The limit of g is going to equal j. The limit of h is going to equal 5. So these are our limit values, p, j, and 5. So this is addition. Remember, we are going to find the limit as x approaches c for f of x, plus we're going to find the limit as x approaches c for g of x, and then we're going to add them together. So the limit for f of x is p, plus the limit for g of x is j, so our result is p plus j. Here's our power rule right here. So what this is saying is we want to take the limit as x approaches c for h of x, and then we'll take that to the power afterwards. So the limit of h of x is 5, and then to the power of 3, we can evaluate that and we get 125. Next one, we've got multiplication and division happening here. So we got the limit of f of x times g of x over h of x. So each of those limits separately, f of x is going to be p times, I'm just going to put parentheses, g of x, so the limit of g of x, that's j, over the limit of h of x, which is 5. So you can leave it like this. You could write it as p, j over 5, but the first one's perfectly fine. Limits of trig functions. The limits of trig functions work the same way as normal functions. Typically they can be solved with direct substitution and limit properties. So let's try just substitution. This first limit as x approaches 0 for tangent x. So I highly recommend to change tangent into its sine and cosine ratio. So the limit as x approaches 0 for sine of x over cosine of x. That's going to make a lot more sense in our head, I think, than it will just trying to go straight for tangent, because we know the values for sine and cosine a little bit easier. So direct substitution would be sine of 0 over cosine of 0. Well, sine of 0 is simply just 0. Sine of cosine is 1, so 0 divided by 1 equals 0. Next up, we have actually the multiplication of two different functions. X is function number 1, cosine x is function number 2, but it's simply just multiplying them together. So the limit as x approaches pi for x times the limit as x approaches pi for cosine x. Find them separately. Well, x, that's direct substitution, that's just pi, times direct substitution for cosine x, we get cosine pi. So we need to remember the value for cosine pi, which is actually negative 1. So we have pi times negative 1, which gives us negative pi. Last up, the notation here means that the whole sine x is being squared. So I'm going to rewrite it as this. The limit as x approaches 0 for sine x squared. So remember, that means we find the limit of the inside and then square it. So sine of 0 is what we're going to find, and then we're going to square it at the end. Well, sine of 0 is simply just 0, so 0 squared equals 0. So those are our trig functions. Now, sometimes it is as simple as direct substitution. Sometimes they get a little bit messy. So let's look at these back here. If we look at this first one right here, we have the limit as x approaches 1 of x squared plus x plus 2 over x plus 1. So we're going to, of course, try direct substitution. So we get 1 squared plus 1 plus 2 over 1 plus 1. Okay, doesn't seem like anything's going to go wrong here. So 1 squared plus 1 plus 2 gets me 4. On the bottom, 1 plus 1 is 2. So my answer is 2. So that was pretty simple with direct substitution. Now, let's look at number 2. We have the limit as x approaches 1 of x to the third minus 1 over x minus 1. Now, this might look familiar from what we did on the other video. So you might have an idea of what's about to happen if you remember that one. If I do direct substitution, 1 to the third minus 1 over 1 minus 1, well, 1 to the third is 1, minus 1, that's 0. And then on the bottom, 1 minus 1 is 0. And this is not going to be allowed. We're not going to be able to divide by 0. And actually, 0 divided by 0 is this special thing called an indeterminate form. 0 divided by 0 is one of our indeterminate forms that we're going to run into this year. So that means there's probably something else that you need to do this. So let's go back to the limit. The limit as x approaches 1 of x to the third minus 1 over x minus 1. Well, we talked about this in the other video, but x to the third minus 1 is actually a difference of cubes. And it has a special formula that helps us factor those. And that would be x minus 1, and then x squared plus x plus 1 over x minus 1. And then we talked about this. This creates a whole. Well, that works out really nicely for us in the simplifying, because now all I have to take the limit of is x squared plus x plus 1. And direct substitution is going to work beautifully in that. So the limit as, whoops, we don't have to write that anymore. We're going to do direct substitution. Sorry. So 1 squared plus 1 plus 1. 1 squared is 1. 1 plus 1 is 3. So the limit of this value right up here, or of this function right here as x approaches 1, is actually 3. So let's do one more. We have this right here. So direct substitution, always going to be my first thing that I go to. Substitute it in. 0 plus 1 minus 1. Okay? On the bottom, substitute 0. So already you should be saying, okay, this is not going to work out well. Finish it up, simplify it. Square root of 0 plus 1, that's just 1, so square root of 1 is 1. Minus 1, that's 0. Divided by 0 Yep, definitely this is our indeterminate form again. So we need to do something else. Now on this one, factoring was very helpful for 2. This one, factoring's not going to help me out very much here. So we need to pull back to another concept from other math classes, and that is multiplying by the conjugate. So the opposite of this right here. So the limit as x approaches 0 of this square root of x plus 1 minus 1 over x. I do not want this nasty thing right here. So the conjugate, x plus 1 plus 1, if I divide that on bottom as well, this is just a value of 1. So it's not really changing the value, it's just going to change the form a little bit. So I'm going to multiply these together. This times this is this squared, so it ends up just being x plus 1. No more square root to worry about. Well, positive, negative, that's going to end up canceling, and then negative 1 times 1 is negative 1. So the top looks much nicer. So my limit is looking a little better on top. Now the bottom, this times this, I'm just going to keep it as x times all of that mess over there. And that looks pretty messy and it might be a little bit nervous, but that's okay because something beautiful is about to happen. If I do x plus 1 minus 1, that's simply just x on the top. So the limit as x approaches 0 is just x on top now. On the bottom, we still have x times all of this mess, but now I have a factor on top and bottom that will cancel out. So now I'm left with limit as x approaches 0 of 1 over the square root of x plus 1 plus another 1. And direct substitution is actually going to work out for us now. So 1 is on the top. Square root of 0 plus 1 plus 1. Square root of 0 plus 1 is simply just 1. 1 plus 1 is 2. So we have 1/2. So the limit of that really crazy looking one up here actually equals 2 in the end when we get rid of that indeterminate form.